Area of acute and obtuse triangles. What is the difference between these three triangles? Some of the things that you should notice are that only the right triangle has this 90-degree angle, our right angle here. Both the acute and the obtuse do not have a 90-degree right angle. A similarity is that they're a triangle and all have three sides. So let's take a look at how we can use a formula to find the area for acute and obtuse by looking at some of the differences that we have from the right triangle. The height of the right triangle is easy to find. It's a side. It does not always to be the side of a triangle. The height of a triangle is also called the altitude, which is a line segment from a vertex of the triangle and perpendicular to the opposite side. So for example, let's take a look here at our right triangle. We know this is our right triangle because we have our 90-degree angle. And as we saw in our last section, our height and our base are the two sides for the right angle. So we need to draw an altitude in this acute triangle so that I can see what the height is. This altitude will make a 90-degree angle with the base. So the H is really this green line that's right there. It is not this side. In this triangle, in the obtuse triangle, I can draw the altitude and drop it from that highest point down so that I make a line that is perpendicular to the base. So then this side becomes the height and this side remains the base. Is the formula for the area of a right triangle true for all triangles? Let's see. Two triangles were drawn to create a rectangle using the base of the triangle as one of the rectangle's sides. So this outer shape here would be a rectangle. We know that the area of a rectangle is base times height. Rotate the triangles so that they cover the yellow triangle. So when I take and rotate this red triangle, I can see what happens, and I rotate the blue, I am really covering the triangle that is there. So after rotating the two triangles, I see that they cover half of the original rectangular area. Therefore, the area of a triangle is half the area of the rectangle, or our formula we were writing, area equals 1/2 base times height. My height is the purple line here that has been drawn because now I have a 90-degree angle for the height. It's 90 degrees and makes a perpendicular angle to the base, or B. How about a triangle shaped like this one? If we draw a rectangle so that the rectangle's base matches up with the triangle's base, I should be able to move the section of the triangle that's outside of the rectangle to the interior of the rectangle so that no parts of the triangle overlap. No parts of the triangle overlap, and I've moved that to the interior. So what fraction of the rectangle is covered by the yellow portion of the triangle? I've created two blue triangles to cover the space of the rectangle that was not covered by the yellow triangle. So now I can rotate these blue triangles and see if I can get them to cover the yellow triangles. So this blue can cover and is the same size as there. So what happens with this blue? If I rotate this around, I can see that it also covers that yellow shape. As you can see, the blue triangles are the same as the yellow triangles, and they each cover half of the original rectangular area. Therefore, the area of a triangle is half the area of a rectangle, or area equals 1/2 base times height. Example, find the area of the figure. First, we have a triangle, so we know we are going to use our triangle area formula. Area equals 1/2 times the base times the height. We're going to say that the 11 centimeters is the base because here's the height that I have drawn. And there's a 90-degree angle between the height and the base. So the 8 centimeters is the height. The measurements of these two sides are not needed for this calculation. I substitute in my values, so I get area equals 1/2 times 11 times 8, and then I see that I have 1/2 times 88, and my answer is 44 centimeters squared. Try these. Find the area of the figures. Let's take a look at the triangle on the left-hand side. I know that we have a triangle, so we're going to use our formula, area equals 1/2 base times height divided by 2. In this problem, we're going to label the base as 11 feet, and then I have a height coming up from the base at a 90-degree angle of 10 feet. These two measurements are not needed for this calculation. When I substitute in my base times my height, I get 11 times 10 divided by 2, and my answer is 55 feet squared. Now for the problem on the right, again, I have a triangle, so I'm going to say my area equals 1/2 base times height. In this case, 16 is my base. And then over here, we have drawn a height that is perpendicular to the base and creates a 90-degree angle, and that is 14. These two numbers are not needed to solve this problem. I substitute in my base and my height, get 1/2 times 16 times 14, and my final answer is area equals 112 units squared. Use what you know to try and figure out how can we calculate the area of this triangle. So if I look at this triangle, I can't, based on this grid, count out how long the base is, how long the height is. So what I can do is I could actually create a rectangle around this triangle. So these are things we know. We know how to find the area of a rectangle, and now we have 3 smaller triangles around the larger triangle. So now that we've broken it into smaller and different shapes, step 1 is to calculate the area of the whole rectangle. So if I calculate the area of this whole rectangle, I have area equals length times width. I get 342 units squared. So then if I calculate the area of all of the triangles, the red, the yellow, and the purple, I can in step 3 find the sum of the triangles, and then in step 4 I would subtract the sum of the 3 triangles from the area of the rectangle, which would leave me with the triangle in the middle that we're trying to solve for. So my area of my red triangle, I would actually count my grid lines along the side to get the dimensions of the base and the height, and we end up with that it is 18 is the base and my height is 8. So this area is 72 units squared. For the yellow triangle, I end up that it is 13 for the base and 11 for the height. And when I multiply that out, I get 71.5. Now for the area of this purple triangle on the left-hand side, I would get 1/2. It has a base of 5 and a height of 19. So I calculate it out and get that. So I'm going to add my red, yellow, and purple triangles together. I get 186. I find the difference of the whole rectangle, which was 342 minus 186. I get 156. This 156 units squared is the area of the triangle in the middle. Area of any shape. This method can be used with any shape as long as you can find the base and height of the triangles that form the surrounding rectangle. So let's go ahead and make a rectangle around this shape. So when I create this rectangle, it actually ends up being a square that I have created that has side lengths of 18. So I find the area of this square, 18 times 18 is 324 inches squared. Then I'm able to take a look, and I've created 4 triangles around the shape I'm trying to find the area of. Triangle 1 is 11 by 11, 11 for the base, 11 for the height, so my area is 60.5. Triangle 2, I have 11 as the base and 7 as the height, so my area is 38.5. Triangle 3 has a base of 7 and a height of 4, so my area is 14 units squared, and triangle 4 has a base of 7 and a height of 14, so my area is 49 units squared. Once I calculate all of those areas, I then take the sum of these 4 triangles and I subtract it from the area that we found of the square. So 324 minus 162 gives us 162 units squared.